pre-calculus. We're going to be working today and talking about domain and range. This is section 1.1 in our pre-calculus book. So the first problem I just want to talk about before we even look at it and talk about anything in the book is just a word problem. It says Eric is selling raffle tickets for a school fundraiser. Each ticket costs $3, and he knows the amount of money he collects is a function of how many tickets he sells. What is the domain and the range for that function? Okay, so we need to know the domain and the range. Domain has to do with what is your variable here. Here your variable is not going to be how much the ticket costs. The ticket always costs $3. What the variable is how many tickets he sells. That's what could change. So we want to know what are the restraints, the restrictions on how many tickets he sells. Well, you might say, well, there are no restrictions. But in mathematics, actually, restrictions can be a lot of things. So what we would say here is for our variable, which is for the tickets. So we've decided our domain is the tickets. And those have to be greater than or equal to 0. So you can sell 0 tickets. The thing you can't sell is negative tickets. And so that's kind of what you have to show in mathematics. That with your domain, you have to say, okay, it can't be negative. Now, the next thing is the range. Our range is what you get out. In this case, our range isn't the variable. That was our domain. Our range is the money we make. All right. Well, that range has to be greater than 0, or it could be equal to 0. So we might make $0. Now you might be saying to ourselves, well, you know, if he spent some money or something went on, he'd lose money, and so it's possible to go negative. For what we have for the problem, our range is positive numbers. So that's kind of our range for this value here. So the next thing I want to look at is just what are the notes on our domain and our range. What I need you to know. I need you to know that our domain is basically what are our possible x values. All right? What are the horizontal restrictions? So, you have some restrictions, I bet, at home. I bet there's times where you're told you have to be in and home by a certain time. And so we all have restrictions. There's certain speed limit I have to follow when I'm on different roads, and there's different restrictions. It's different if I'm on a highway versus 36th Avenue in front of the school building. Now let's talk about the range. The range is the possible y values. And visually, that's our vertical restrictions. And it's here what we can possibly get out for an answer. All right? Now, we are going to be using f of x for our function. So a lot of times instead of the y values, we're going to be saying, oh, nope, it's really our f of x function. So it's going to be what can our f of x be. So it's the resultant after you have a function. And the domain is what could your variable be. So even when we say x here, I should even be using the terminology, it's what our variable could be. Okay, so it's what our variable could be. Our range is, okay, that's what you can get out of something. Let's go look at the next thing. Oh, my arrows just aren't working for me lately. Okay, so now, the function f of x is graphed. What is its domain? So if you remember, the domain is our horizontal. So here, our blue graph goes in between, it looks to be -2 and +3. So the way I would show my domain, and I can just use a D to show domain, is I would say my x values have to be less than or equal to 3, because it could be a 3 or anything less, but at the same time it has to be greater than or equal to -2. Now let's talk about our range. Our range, I'm going to do a blue, and I've got kind of a little smaller range here. Looks like my blue values here could be, for my range, the range, my y values, my vertical values, could be anything below 6 but above and equal to 4. So my y has to be less than or equal to 6, but greater than or equal to 4, because that's what my graph shows. So I'm going to get rid of my dots here, and I'm going to show you that again. So for my x values, the minimum it could have been was the 4, and the y value, sorry, and the maximum it was 6. For the x value, the minimum was -2, the maximum was 3. So it's really about saying, okay, what are my constraints? What are my restraints? Very similar concept there. So let's go to the next one. All right, the function f of x is graphed. Another one. What's its domain and its range? Here, my domain, again, has to go with my x values. This x value here starts at -3, and the highest value it goes up to 5. So my domain is anything less than or equal to my 5, and has to be greater than or equal to that -3. For my range here, this is my highest value right here at, I'm going to call that 4, all right, and then my lowest value is at -3. So my y has to be less than or equal to 4 and greater than or equal to -3, okay? All right, in the next one over here, another one, we have domain and range. Now this one's an interesting one. When I look at my minimum, for my domain, definitely my minimum is at -1. I know that's a little hard to see here. My maximum, however, has an arrow right here. That arrow indicates it can go on forever in the positive direction. So the way that we indicate that is we call it positive infinity. For the range, the lowest point we have is right here at this -2. So -2 is what it has to be greater than. The highest point is, again, infinity. So we're at positive infinity. Sorry, my 8 is a little bit... My infinity sign looks a little bit too much like an 8. But we are there at positive infinity. Let's look at some more. Here, I'm going to move down to this problem right here. For my x and my y, there is no, because in the negative direction and in the positive direction, it goes to an arrow, and that's for my x value in either right or left. It's all real numbers. There's two ways I could show this, that I could either go, has to be less than positive infinity and greater than or equal to negative infinity, so I can show it there. Another fun way, or not appropriate way, is x can equal all real numbers. See my goofy R? That goofy R indicates all real numbers. So that's saying all real numbers. That's what I just wrote there. For my range, while I have no upper range, the lowest it could go, it looks to be like -3. So I would say y has to be less than, or excuse me, greater than or equal to -3, but then there is no upper range. So that's what I would say positive infinity. One last one here, my domain, my x, has an upper limit of positive infinity and a lower limit of -1. My y has an upper limit of positive infinity and a lower limit of 0. No, it doesn't go below the 0. All right, what is the domain and the range for each of these problems? Ben charges $10 an hour for mowing lawns. The variable, that's our domain, is our variable. The variable is how many hours. So hours is our variable. So the restrictions on hours is that it just has to be greater than or equal to 0. You can go 0 hours for mowing lawn, 1, 1.5, 1.2, 1.5. There is no restrictions as far as how many hours he goes. Then for our answer, f of x, or I could have put y here. Again, only restriction is that we're dealing with positive. You can't have negative money when you're mowing lawns for people. Maria charges $25 per hour for tutoring math, with a minimum charge of $15. Okay? Now Ben, if he worked a half hour on his mowing of a lawn, you'd have to pay somebody, he'd get paid $5 if it cost just a half hour, say you have a really tiny lawn. Maria got smart. She said, hey, I'm not going there. I'm not playing. If I'm going to get involved, if I'm going to be here tutoring, the minimum you're going to pay me is $15. So for Ben, I had to say here that it could be 0, it could be anything. Maria kind of says I'm not playing, but that's, again, the output. how many hours she has, or our domain, is still has to be, it could be 0, but it could be up to, 5 hours, we don't know, has to be greater than 0. But what we get out, our money, our function, has to be greater than or equal to $15. She says, we're not going to call it tutoring if it's 0 hours. Unless I get paid $15, I'm not going. Number 3 here. So let's look at number 3. Now we have a variable and we have what comes out. 15x minus 2. What are our restrictions? What possible number could we put in there for the x? You know what? Any possible number. So our domain, we would write here as all real numbers. That's what x could be. There's no restrictions. Same thing for the range. It could be a positive number, it could be a negative number. If you put in a really high positive number in for x, say like 10, 150 minus 12, we're going to get a positive answer. If we put in a negative answer, you're going to get a negative answer. If we put in a fraction, you're going to get a fraction still, or a decimal. So the range here is also this sign for all real numbers. There's no restrictions here. There's nothing we can't do. Now the domain, when we look at my variable, my x, my domain for number 4, says, well, you know what? Just because I have to square something, I can square any number. I can take any number times itself. So for the domain, there are no restrictions. Where the restrictions come involved is in the range. Because no matter what number I put in, I have to square it. So even if I put in a positive number here for this x, the answer in the end will still be positive. But if I put a negative, the answer in the end is still positive. So my answer in the end is what I'm trying to say is always going to be positive. It's always going to be greater than 0. Because any number, when you square it, it's even if it's a negative times a negative, it's positive, or positive times a positive is a positive. So you're always going to get a positive number there. With 5, there is a restriction. We don't know, or we won't work with how you can take a negative of a square root. So we do know, you might have learned something like that in Algebra 2. There is kind of a way to show it, but for the most part, we kind of say that's a restriction. We don't go and take a negative of a square root. So whatever inside of our square root has to be positive. So the restriction for that variable is that x plus 3 has to be greater than or equal to 0. If x plus 3 has to be greater than or equal to 0, x has to be greater than or equal to 3. That's my domain. My range, well, if I always have a square root of a positive number, my range, what I get out for an answer, will always be positive. So I'm always going to have a positive answer. It could be a decimal, it could be still a square root, but it's always going to be positive. So now this is the worksheet that I want you to work on right now. It's just stating the domain and the range. The big thing we're looking for, if it's a square root, you can't have it equal to 0. Or it has to be, positive, so it has to be greater than 0. So right here when we see 7, you would be saying to yourself, okay, x plus 1 has to be greater than or equal to 0. One thing we have to be careful of is a denominator. Denominators can't equal 0. You can't take 1 divided by a value. So let's look at problem number 5 here. Problem number 5 says we have 1 divided by x minus 2. Well, that denominator cannot be 0. So x minus 2 can't equal 0, which means x can't equal 2. That's in my domain. X can't equal 2. Well, my range, really, it just says that you're never going to have a 0. So for my range, my f of x, the only answer you're never going to get is 0, because you can't take 1 divided by 0. Every other answer you will get. You will get a negative, you will get a positive. And we're going to talk about more problems like this in class, but I just wanted to go over a few examples.